Hey everybody, I'm Alex Glow with Hackster.io. We're getting ready to start here. We are here today to talk about create intelligence at the edge with the Ultra96, which is a board that we're about to tell you about. If you're not familiar, you can check out some previous YouTube videos that we've done, including an unboxing and some demos with Robert and Sahaj from 96 boards. So with me today, we've got Brian from Avnet, who's going to give us an overview of the Ultra96 from the Avnet perspective. We've also got
Hi,
Craig
Alex.
from, oh hey, what's up, Brian?
Hello.
We've also got Craig from Xilinx, who is talking about the Zinc UltraScale Plus SoC, or MP-SoC specifically, which is the FPGA that's on the board. And then we've also got Robert and Young from 96 boards, who are going to talk about the 96 boards ecosystem. It's a really cool thing that I actually think is pretty exciting. And their collaborations in the past with Avnet and Xilinx. What's up, everyone?
Hello there. Hi.
Hello.
Hey.
Hello.
So we have a contest running, which is why we're doing this webinar. The contest runs until the middle of October. It's on Hackster.io/contests. Just check out it's got the same name as this, Create Intelligence at the Edge with the Ultra96. And then also, just so you know, on September 25th, we're doing a virtual workshop that we'll do last for an hour or so, and you'll actually learn how to use these tools, and there's still time to sign up for that if you want to get involved. So yeah, I have actually an Ultra96 here. I think it's a pretty exciting board. We've done, as I mentioned, an unboxing with it, and we talk a little bit about the fact that you've got this Xilinx Zinc chip on here, and also the 96 board's form factor. You'll notice that there's this sweet pin connector and some other, like a high-speed one as well. I think it's really well designed. You've got this beautiful sort of metallic enclosure protecting this heatsink and fan in here. I think it's designed for high performance because you got a lot of cooling power in there. I can't wait to hear from you guys about what makes it so exciting and why we need all that cooling for so much processing. All right, so let's just jump right in if y'all are ready. Yeah?
Sure.
All right. So our
Ready.
first, my first victim is going to be Brian Fletcher from Avnet. So what is the Ultra96, Brian?
Well, is it okay if I share some slides?
Please do.
Okay, let me put that up. Okay. All right. Can you see that? Okay.
Looks great.
Okay. Well, the Ultra96 is a $249 single board computer based on the Xilinx Zinc UltraScale Plus MP-SoC. So that's what we're talking about today. That's the highlight of the board. It is designed to the Linaro 96 board's standard form factor. It's designed after the consumer edition specification with the ARM processing system on the MP-SoC combined with the Xilinx programmable logic. It really is ideal for a lot of advanced applications such as artificial intelligence, machine learning, embedded processing, and robotics.
Sweet. So this doesn't just come alone, right? It comes as part of a kit. What does it come with?
Yes, it does come as part of a kit. I've got an image of the kit shown on the screen here. You can see the Ultra96 up in the right-hand corner. It does ship with the 16 gigabyte micro SD card that comes preloaded with embedded Linux. We put a small bit of documentation, the quick start card, just to get you going and get you pointed in the right direction. And then we also include a license voucher. This gives you a license to use the Vivado Design Edition with SDSoC, so that it really gives you everything you need to start doing some great designs with the Ultra96.
Oh, that's pretty awesome. I also like that you've labeled that cool box, and I would agree it is a cool box. It's got this sweet picture of, like, you know, an AI face sort of dissolving into particles of what I assume is logic. So besides the Zinc UltraScale Plus chip that you mentioned, what else is on the board?
Well, yeah, so the MP-SoC definitely is the centerpiece of this board, but there's a bunch of other things, and a lot of this goes back to the consumer edition specification from 96 boards, but you'll see that we do have 2 gigabytes of LPDDR4 RAM on the board. There's also the micro SD port. We talked about that previously. There's some user LEDs and buttons, just some basic things. You have a bunch of connectivity. So we do have video available through a mini display port. For communications, we have a Wi-Fi, Bluetooth radio on board. We have several USB connections, two that are USB device connections and one that's a USB host. And then we also have a couple different expansion ports available. You showed those when you held up the board, the 40-pin low-speed expansion connector, as well as a 60-pin high-speed expansion connector. So, you can do quite a bit with the board, with the connectivity that's available, and then it also gives you the ability to add things to the board to expand it. So
cool. And those are called mezzanine boards, right?
Yes, they are. And again, that's all part of the 96 board story. There's several 96 boards mezzanines, and since this board is designed to that standard, they'll plug right on, and
so cool.
So mechanically, it's all going to fit together.
Beautiful. So how does the Ultra 96 compare to the other 96 boards? Like, what makes it different?
Well, yeah, sure. So I definitely won't admit to being an expert in all of the 96 boards. I need to get Robert and Yang to talk about that. But it is similar in that it is based on an ARM processing system, and it is designed to the same form factor with the expansion connectors and the various I/O connectors. So it'll look and feel exactly the same as a lot of the other 96 boards. The major difference is that this one has programmable logic. So that's really Xilinx's specialty. It's what they've been doing for 30 years now. And the Ultra 96 with the MPSoC device does have a pretty significant chunk of programmable logic on the chip that's accessible for people to use.
Super cool. So how much programmable logic exactly does the Ultra 96 have?
Oh, so it has 150,000 logic cells. The logic cells consist of flip-flops and lookup tables. You've also got some distributed RAM and block RAM, and then 360 DSP slices. If for the listeners who may be familiar with some of Xilinx's previous families, the ZU3EG device that's on the Ultra 96 is similar to the Zynq 7030 device in terms of programmable logic resources. It's about 50% larger than the Artix 7A100, and it's comparable in logic resources to a Spartan 6 LX150.
Super cool. So let's dive a little bit into what exactly programmable logic is. What can I do with it?
So, it's really a blank slate. You can design any kind of custom thing that you could possibly think of. I think traditionally it was primarily for glue logic. I think that's how Xilinx got their start. But there's just such a massive amount of things that you can do with it now. Typically it's designed, the logic is designed with Verilog or VHDL, but with the SDSoC that's included, the license that's included in the kit, you now have the ability for a design environment manager that can take advantage of high-level languages and synthesize those straight into the gates. So when we talk about the accelerators that you can design in Ultra 96, it's the programmable logic that makes that possible.
Huh. Awesome. Are there any extra accessories that you'd recommend that don't come with the standard kit?
Yes, there definitely are. For one, you're going to need a power supply to power the board. For people who are already using a 96 boards unit, then perhaps their power supply would be compatible with the Ultra 96. But we at Avnet, we offer three, two through Avnet and one through Farnell. So you'll see the first one, our least expensive one, is a 2 amp device for $8.50. That has a US plug only. The other two offer a little bit more power, and they are a little bit more expensive in the $20 range, but they include international plugs for all over the world. So those are the power supplies that we have to offer. I'd also highly recommend a JTAG UART pod. If you're looking at the picture, that's what this little accessory board is here. So on the Ultra96, UART is pinned out to a 3-pin header, and then the JTAG connections are on a 7-pin header. And normally you'd need some sort of external transceiver to make those operational. We've designed that onto this little pod so that you can get a USB to UART access, so your PC will easily communicate and see terminal messages with the Ultra96, and then also the JTAG connector. So when you're using the Xilinx tools, it can easily communicate over that JTAG port to the MPSoC device. So I definitely recommend the pod. It's only $39 and will give you a lot of functionality, and it fits so nicely with the Ultra96.
Nice.
The last thing are the mezzanines that we've talked about briefly so far. One that we've done a lot of work with so far is the Seed Grow starter kit. It's a sensor mezzanine. There's a lot of really neat things. Yeah, it's a lot of really neat things you can do, and I know there's several others that we're looking at and or are in design. So you can go to 96boards.org and look at the various mezzanines that are available and see what might fit with what you want to do with Ultra96.
I've definitely checked those out a bit. There's a lot of really cool stuff. There's like audio stuff, there's video processing stuff for cameras and things that would be super useful with this. And I love the Grove starter kits because those include both sensors and actuators. So you can build like basically an entire application with just little plug and play modules. It's so cool. And
yes, yeah, absolutely.
Yeah, and I love also that there's international options for the adapters. I'm actually really curious about like where our viewers are from, and I'm looking forward to like checking in on that afterwards. It'll be so cool. So where do you get one of these?
So we sell them through Avnet, but Avnet is also made up of Newark and Farnell over in the UK. So you can get those at avnet.com, newark.com, or farnell.com. Any of those sites online, or you can also go to any of your local Avnet sales offices around the world to request to buy an Ultra96.
Fabulous. So then you wouldn't even have to wait for shipping and stuff.
Yeah, I can show you like on the website here. I've just pulled up the page for Ultra96. You can see we've got 1,400 of them in stock. So we're excited for people to start using these and take advantage of them.
Cool. Sweet. Well, let's move on and see what Craig's got to say about the Xilinx side of this. Thank you so much, Brian. We'll come back and like chat again in a second. But for now, Craig, can you tell us a bit more about the Zynq UltraScale Plus multi-core processor SoC that's on this? So the MPSoC multi-core processor SoC.
Yeah.
Cool.
Yeah. Thanks, Alex. Hey, I'm going to share a slide or two here, if that's okay. How about this one? It's coming.
That's a good one. Yeah.
Let's push that button. See what happens. Oh, look at that. Cool.
Fabulous.
So yeah, I'll just I'm going to kind of march around. This is a kind of a floor plan of what the Zynq UltraScale MPSoC looks like, and I'll just kind of march around the periphery of this thing. You know, first and foremost, it's built around the ARM Cortex A53 processor subsystem. Some of the Zynq UltraScale Pluses have 2 ARM A53s. Some have 4 A53s, and obviously that's a 64-bit processor that I suspect our listeners are familiar with. But along with the A53, we've got a pair of Cortex R5s. Those are real-time processors. Those can be run independently or in lockstep. And lockstep's like really important for safety applications, automotive, things like that. So those are two of the main processors in there. We also have the Mali 400 MP2. That's the GPU that is in use. Very popular GPU in a lot of ARM SoCs. We also have this thing called a platform management unit that might not be quite as familiar to the listeners here as the other blocks. And the platform management unit is used for, among other things, the Zynq MPSoC, the Zynq UltraScale Plus MPSoC has a number of power islands. So you can power different parts of the chip up and down. And Yeah, that's cool for a couple of things. It's useful if you want to, with very fine granularity control the power consumption of the boards. You can get very low power consumption, but it's also really important in safety applications. So you want to have like the R5s on different power islands if you detect a flaw or something like that. So having that level of control makes it a good candidate for use in safety applications.
Hmm.
FPGA acceleration, that's the programmable logic that Brian was talking about. I'll talk about that more in a second. The video codec we have, that is a hardened video codec. It does 8K, 4K video at 15 frames per second, or 4K video at 60 frames per second. It does
Dang.
H.265. So just in full disclosure, there's multiple members of the Zynq UltraScale Plus family, and the device that is on the UltraScale Plus does not have the video codec. So that's a higher end product, or a higher end Zynq UltraScale product. And Ultra96 is a little bit more of a kind of a value board, if you will. Maybe cost optimized might be one way to look at it. But there are other boards in the Xilinx as well as in the Avnet offerings that do have devices that have this video codec. And the video codec, the VCU, that's a lot of capability hardened in there. And that is used for things like video conferencing, surveillance. Data centers actually do a lot of video codec work. Not a lot of Zynq. Typically, the VCU stuff in the data center, though, we do that in our other products that we call the Vertex products. But the VCU in the Zynq UltraScale is very powerful. Then we have the memory subsystem. It handles DDR3, DDR4, LPDDR3, LPDDR4. We have a number of high-speed interfaces on the chip as well. And similar to the VCU, for instance, we don't have PCI Express in the Ultra96, mostly because don't really need it. It's not really a plug-in peripheral card. But we do support a DisplayPort, and we do support USB 3 on Ultra96. So it's making use of that dedicated circuitry. And then finally, in the configuration security area, this FPGA acceleration block that we mentioned just a second ago, to configure that FPGA acceleration, you have to add, or what we call download, a bit stream. So there's a bit stream that gives the programmable logic its personality.
Right.
And in a secure application, you want to make sure that that bit stream hasn't been tampered with. So we have a ton of security features built into the Zynq UltraScale Plus MPSoC that allow you to securely and know that that bit stream hasn't been tampered with. So that's what that does. And there's a lot of other config and securities features built into MPSoC.
Oh, that's fantastic. And the security stuff becomes so important when you have a connected board that has Wi-Fi and BLE like this one does.
Oh, totally. And it's used in, industrial and scientific and utilities and things like that. So utilities right now are very sensitive to connecting things to the web, or to the internet, I should say.
Understandably.
So, yeah, you would think you don't want to shut down your city.
Yeah.
So the config and security stuff, as well as the fact that it's an NA53 that has a lot of virtualization capability, together make it a very secure platform.
Really cool. So you
Yeah.
mentioned a little bit about how this compares to other SoCs. Is there anything specifically that sets it apart?
Yeah, so SoC means system on chip, and every SoC has different features. But probably the big difference between the Zynq UltraScale Plus MPSoC versus other SoCs is this FPGA acceleration block. So
Right.
other SoCs have perhaps different computers or different dedicated acceleration engines. What the programmable logic block allows you to do, the FPGA acceleration block, I use the terms interchangeably. What it allows you to do is really create whatever type of acceleration block that you might want to do. So it gives you almost, infinite's the wrong word to use, but it's like Brian said, it's really a blank slate, and the stuff that people put in this is pretty amazing.
Yeah, and we hear that sometimes people can get paralyzed by having like too much ability to do stuff, which is like a good problem to have, right? But like, you
Good,
know, so
it's
like
a good paralysis.
I know, right? Yeah.
Yeah.
It's a good thing. But
Yeah, yeah.
more specifically, like what benefits does it bring and when would someone want to use it?
Yeah, so there's a bunch of reasons, and it really kind of goes back to Xilinx's roots. So I talked about the acceleration thing. So
Hmm.
that's one application. So you've got some code and you're executing your code, and you realize, oh, this let's say compression algorithm is taking way too many clock cycles to execute, and it's affecting the operation of your end product. Well, you
Mm.
can take that compression algorithm and implement it in programmable logic gates and get potentially orders of magnitude more performance, higher speed out of it. So that's the concept of acceleration. You're taking an algorithm that runs slow in a processor and doing it in programmable logic gates. And so you're not doing the fetch execute that a processor needs to do. You're just building a hunk of hardware that does it instead. That's like one thing you might do. I actually got a cheat sheet for myself, so I want to make sure I don't miss anything. Um, so I've only given this speech a gajillion times. Um, so another thing that it's really good at is, let's say you're doing a product that has to conform to some specification, and the specification is not nailed down yet. You can put that specification into programmable logic, and that gives you the capability of continually modifying how you've implemented that specification over time. So that's a real key point. I might talk about that again in a little bit. But another thing is in kind of the SoC world, you might pick out a part that has, let's say, 4 UARTs, and then all of a sudden marketing comes back to you and says, oh, 4, I'm sorry, I meant 40. So you could easily, and it's kind of tongue in cheek, but you could easily put 40 UARTs in programmable logic. And the message behind that is you don't really need to be nailed down anymore by the peripherals that a particular supplier has selected for their particular SoC. And it also gives you the flexibility to continue to change those on the fly. So that's a really strong point.
Fantastic. So people are probably more familiar with ASICs or application-specific integrated circuits, and how is this different from that?
Yeah, so that's really one of the reasons FPGAs have been around as long as we have. I talked about the evolving standard thing. That's a really key point.
Hmm.
And one of the other things is, when you do an ASIC, you have to lock down the functionality that's in the ASIC. With an FPGA, not only can you change the functionality as the design progresses, you can change the functionality once the design has been fielded. There's FPGAs in orbit right now
Whoa.
that, yeah, seriously, not MPSoCs that I'm aware of, but we have a family of radiation hardened parts that are up in satellites now, and what they're doing is they implement different DSP algorithms, and basically the guys that operate the satellites are able to upload new images to the FPGA and make it a different type of DSP algorithm or downlink a data in a different format. And it allows them to use perhaps even a smaller part with a smaller power envelope, and they just change its personality on the fly. So it's not just changing the personality of the board while it's under development. You're able to do it in the field, and that's what the F in FPGA stands for. It's a field programmable gate array, and
Wow, I love that.
it's a really powerful paradigm for really powerful capability. Anyway, one thing I did want to mention is that, like I said, there's a couple of different versions of the Zynq UltraScale Plus. There's a dual-core A53, there's the quad-core A53 with the GPU, and that's the one that is in the Ultra96. And then there's a quad-core A53 with a GPU and the codec. That's called the EV family of devices, and that's on some of the higher-end boards that we have.
Brian, for you, for people who want to get started with programmable logic on the Ultra 96, what common challenges do you sort of anticipate people facing, and how would they get over that? What resources can you recommend?
Yeah, so I mean, the common challenge is, where do I find stuff to begin with?
Right.
And I mentioned the quick start card. that you will find actually inside the box, but that doesn't give you a whole lot of information. It's just a small card just to get you going. So a good place to go is the zboard.org website. It's also cross-linked to ultra96.org. So this is where Avnet keeps all of their documentation related to any Xilinx SoC or MPSoC board. So you can see here, I can go under products and go to Ultra96. So this is a good starting point to get anything related to Ultra96. You can also go to the 96 board site, like the Linaro specifications are all hosted here, as well as the mezzanines and all of the things related to 96 boards. There's our image for the out-of-box, the out-of-box image that's on the micro SD card is hosted here at the Linaro site. There's also other OS options that are available here. So a lot of good stuff on 96boards.org. And then we're also highlighted on the 96boards.ai site. So in terms of information, those are 3 excellent sites where you can get information. We also have community forums back here at ultra96.org, as well as the 96boards.org. So you can post your questions on either site, and we're monitoring those, and we'll be able to answer them. I know that Avnet and Xilinx have had a good relationship with Adam Taylor. So Adam Taylor, through his MicroZ Chronicles blog series, has highlighted Ultra96. So I'd definitely recommend that. I'll go find it and put a link in the chat here. But so Adam Taylor's MicroZ Chronicles. The last thing is if you really want to interact with us one-on-one, I would highly recommend that you come to the Ultra96 open hours that the 96 Boards organization hosts. And so that, we make sure that we have someone from our team that's available to answer live questions during that open hour session.
Oh, fantastic. And I think Robert's going to talk a little bit more about that if anyone's curious. Sweet. Let's, speaking of 96 boards, let's move on to Robert and Yang. Specifically Yang, who and what is 96 boards? What's your origin story?
Hi everyone. 96 boards starts with a quite simple idea really. So 96 boards created about 3 years ago by Linaro, where we have a bunch of engineers and also our member engineers who are working on the latest and the software stack, actually all the way from the bootloader to kernel to the specific segment market applications software stack in an open source, completely open source way. Then the problem we have, especially at that point, is we are looking into the latest Arch 64 V8 architect hardware to work on the latest software with. But there aren't any, and the only ones which are available cost you about $25 to $300, and even that you can't get it. So we were thinking, why can't we have a latest and greatest SoCs on a development platform where it's accessible by all the software developers who are interested and willingly to work on the software product with. And that's basically is what we started. It's a very simple idea, and to resolve the problem which we have, for our daily work. But then since starting to roll from them, and because we see this is not just a challenge for ourselves, but actually a challenge for the ecosystem at large. And we see people who are from the silicon vendor side, we see from the ODM side, we see from the people building product and writing applications, they all facing the same challenge to have the hands on the latest and greatest SoC and ARM-based SoC technology. And it's not something easy to do. And there are a bunch of the EVB board which is done by every SoC vendor they have. But those are almost impossible to have a common software base, and interoperability is probably near to none. So this is why over the course of the last 3 years, we're starting to see more and more companies join 96 board from the SoC vendor, from the OEM, ODM vendor, even from the software service vendor, cloud service vendor. So they join 96 board to trying to actually take advantage of this open platform specification, where people can coming together on a joint platform. We're really focus on the keyword where it's marketing keyword really, is a standardization and the differentiation. So we standardize things where it doesn't matter and doesn't really make sense for people to reinvest. Every company has to reinvest doing the same thing different way. So we're trying to standardize those and then encourage and focus, direct people's energy in things where really matters, really create differentiations, and where we believe the value really comes from. And this applies both as silicon vendor and also people from the downstream product development as well. So that's what the original story. And we are a bunch of idealism and who really love what we do, and building software, building our own hardware for them. And so that's pretty much where we are.
Wonderful. So bringing us up to the present day then, Robert, what have you all been up to recently? Also, I love the little tux penguin back there.
It's covering my doorknob.
Ah.
Yeah, so no, but yeah, this is actually an official tux penguin from I think 1998, back when penguinpower.com was around. So it was given by one of the original Linux International board members. But yeah, cool. So 96 boards. What are we up to now? So I want to talk about a few of our initiatives. Basically, once you get your Ultra 96, or whether you're thinking about going to get your Ultra 96 board, how can you start getting involved with our ecosystem? And so over the past couple of years, like Yang mentioned, 96 boards hasn't been around for that long, but over the last couple of years, 96 boards has really been trying to put together a portfolio of multi-purpose initiatives and activities that really create an engaging community for you to kind of either get into the community and develop, or for you to just kind of enjoy the ecosystem. And some of these initiatives that I'll start with the ones that I enjoy the most, being open hours, right? So like as Brian mentioned, every week at 4 p.m. UTC, I host a podcast, or a video live stream podcast. And it's so much fun. This is probably the best part of my week. We bring in people from all over the STEM spectrum, try to relate it closely as possible to 96 boards and our ecosystem. We do interviews, we take questions. We are joined by our partners, such as the folks from Avnet and Xilinx, to interact with our community and just kind of have fun. So I definitely encourage everyone to go check out 96boards.org/open hours if you have a chance, and join us in that initiative. Another one of our initiatives that we recently launched is our mezzanine community, and talking a little bit more about mezzanines and what they are. So like, compared to what a Raspberry Pi hat is, or what a BeagleBone cape is, mezzanine is to 96 boards as a Raspberry Pi is to the hat. And so with that, we tried to create a little repository / community that's dedicated to kind of evolving the mezzanine initiative, right? So if anyone is interested in either developing your own initiative, accenting some sort of functionality I have a bunch of 96 boards here, accenting a bunch of functionality on one of the 96 boards, then you can go to this repository. We've provided you with templates in a variety of CAD software, so you can go get your Eagle CAD template, your Altium template, or your KiCad template if you're an open source person, and you can start developing your own mezzanine. So this is a way for you to get involved with us, get involved with other people, other hardware professionals, and kind of practice your skills at developing hardware. And then, of course, once you get it going, you've adopted the 96 boards ecosystem for yourself, and that's kind of a fun way to get involved with us. I'm going to go down a list of a couple more, and then I just want to remind everyone, I don't know if it was mentioned yet, but there's a workshop on the 25th that I will be also kind of elaborating a little deeper on these topics. But one more initiative that I really, really enjoy is our projects org. So 96 Boards has a projects org at GitHub. So github.com/96boards-projects. In this organization, what we've tried to do is we've tried to create a situation for people to create foundational use case projects using 96 boards, then hosting them under the org, but we give you maintainership and ownership of your own repository. So once you get into this org, then you can manage your own repository inside of our ecosystem to kind of grow your project and create more use cases on top of your project. So this is kind of a good way to get involved with our partners. It's a good way to get into our ecosystem. And it's a nice way to just kind of have fun and play with the other projects on there and maybe collaborate or contribute to some of the other projects on there. One last initiative that I'll mention, and of course, anyone who wants to know more about these can reach out to me or join the workshop on the 25th, but is an academics initiative that I will hopefully be talking about a lot more in the coming year. But it's called Open Source Academics, and our goal is to create a kind of bridge between industry and academics. It seems to me, at least, being involved in a lot of academic institutions and STEM programs, that the kind of interactions that go on between industry and academics seem to kind of lose themselves a bit. And so our goal is to create a little bit more of a communication channel and incentivize the participation of students in the industry world, but as students. Also, we would definitely like to get more students into the open source world. So that's kind of something I really like.
Yeah, that'd be sweet.
Yeah.
Awesome. Back to Yang, what is 96 Boards AI? I have a note here about 96 Boards AI. It sounds super cool. What role are you playing in this space? And how does this relate to the Ultra 96?
Yeah, so 96 Board.ai is actually one of the initiatives which Robert we mentioned about. As I just mentioned, the 96 Board, we are using the latest and greatest SLC technology, which really represents the the cutting edge of from not just one but all segments we are involved in, from the tiny little IoT device to the embedded gateway to the from the edge to the cloud to data center. For very recently, actually 19th of March this year, we have launched the 96.AI initiative with multiple SoC vendors and partners such as Avnet and Arrow, etc., to really pushing out a range of 96-board products, which built by our partners, delivering very specific AI acceleration technology in different, silicon fabrics, in the form factor of FPGA, DSP, standard CPU, standard CPU or GPU acceleration, and all dedicated ASIC or on die. So this is actually one of the first time which we actually see in the industry that make this really possible and accessible to general developers on your desktop. And because otherwise these are really behind closed doors and very difficult to have access, even for the engineers working in the SOS company, because we wouldn't able to get to the access to this level. And what's best is with a good and well supported open source stack from top to bottom. So this is what really 96 Board AI created for. This is why all the partners, including Avnet and Xilinx, are one of the founding members of this initiative. Make this really interesting. So what is it related to 96 Board? So Ultra 96 was actually one of the flagship of 96 Board, actually the flagship of 96 Board.ai products on the 96 Board.ai homepage. It's, as I said, it's the first time we brought out previously perceived only accessible in a cloud, in a heavy, very expensive development kit technology, really down to everybody's hands. And after the launch, quite frankly, and it took us a little bit by surprise in terms of reaction we got, because people come to us, we can't believe how you guys actually did this, right? In a price tag with such low price cost range, but such amazing technology. Again, I need to highlight, this is not 10 years, 11 years old technology. which you see elsewhere. This is latest and greatest SoC technology, and with a well-supported open source stack. So, and with, so far we are really seeing some of the really interesting usage of such platform, Ultra96. They're not only limited in the typical embedded development or application, for specific market. They're actually ranging from the application development to the algorithm developers. And in some cases, we know people contact us, say, hey, we are optimizing our own specific neural network for a specific applications. And even more so, we have company, silicon startups who actually were building ASICs. We're talking about ASICs. They're actually using Ultra96
Nice.
as a platform to build an ASIC. So I thought this is actually quite amazing what platform like Ultra96 can enable. This is what 96.ai was created to achieve.
That's true. That's one of the strengths of FPGAs, is that you can use them to prototype ASICs, and then once you're happy with the setup, you can turn it into its own, like a more permanent form factor.
Yeah, this really resonates to what Craig has said, that this really give people the tools and the possibility actually doing stuff before they have to, commit to say, hey, this is it, this is our chip is going to look like. But people just didn't imagine they can do this at such low cost, easy to access, well-supported platforms like this.
Yeah, it's kind of incredible. I think we're going to move on to the Q&A at this point. So just to remind people, you have a Q&A button at the bottom of your screen, and we're going to go through some of the questions. Some of them have been answered in text already, but just for the video watchers, I want to go over those really quickly again. So thank you, Craig and Robert, for jumping in. Hopefully you won't mind answering a couple of those again. So Craig, you answered this one. Tim asked, other than USB, is there another way to connect two cameras? CSI, parallel?
Yeah, we have, we're going to be supporting MIPI CSI in the next version of Linux, the next Linux board support package that we release. That's going to be in the November timeframe.
Oh,
and
fantastic.
that'll be pointed to it on the Avnet website.
Wonderful. An anonymous person asked, I am new to this area of development. I wanted to ask and confirm, the separate OS from the programmable logic is what allows it to be remotely updated in the field? So you would use, contact the OS and then use that to reprogram the FPGA, or? Yeah.
So the way it works is there's inside of the Zynq UltraScale Plus, there's a port called there's a port, and it's basically a memory location. You can think of it that way.
Oh.
So it's a hardened memory location. The bit stream that contains the personality of what you're going to put into the FPGA logic, that's a file. So you simply copy the file to this location, and the file is constructed such that as it passes through this memory location, the FPGA logic does different things. And then when you're done copying the file, the FPGA logic starts up automatically. And that's the default way that it operates. You can have it wait a little while to start up. You can have it wait for like an external event. You can have it wait for you to program some other stuff. You can program that file from a Linux call that we support. You can program it from, if you're not running Linux, which, it's sacrilege to say on a Lenaro call, you may not be running an operating system, or you may have not started the operating system yet, and U-boot can automatically copy the bit stream up, so the bit stream wakes up before the ARMs wake up. Sometimes you want that. You can also set it to, so there's a whole lot of ways, but fundamentally at the very lowest level, you're copying a file to a memory location, and then the programmable logic just wakes up.
Cool. I realize there's some cool terminology around this. I love the description of personality, and yeah, it's I keep saying